Hello, pre-calculus students. Today we're going to do the second part of our lesson on composite functions. Remember that a composite function, you can think of it if function f is, if f is a function of u and u is a function of x, then f must be a function of x. And that's how we get composite functions. So u would be g of x. That's our that's when I said u is a function of x, u is equal to g of x. So f of u would be f of g of x. And today we're going to talk about the domain of a composite function. And sometimes those can be really fun to find. So it helps to know some standard ones. If you have a polynomial with real coefficients, and I'm picky about that, polynomial with real coefficients, the domain is all real numbers. That means you could stick any x value you want into the polynomial and get a real number y out. The absolute value function has a domain of all real numbers. The square root function, the domain is only non-negative numbers. The reciprocal function is any value of x except 0. And the greatest integer function is all real numbers. So if I take a look at these two functions, we know that whatever is under the radical has to be greater than 0. So I take that number under the radical, make it greater than 0. So the domain of this is x is greater than or equal to 5. If you try 4.99, which is not greater than 5, you get the square root of a negative number, and that's bad. If you try 5, 5 minus 5 is 0, square root is 0. That's okay. So when we graph this, you can tell that this is just a square root function translated 5 units to the right, which means normally the square root function starts at 0, 0. So now it's going to start at 5, 0, because x has to be greater than or equal to 5. This function, the only place where there's a problem is if the denominator is equal to 0. That's the only number that would not give you a real number value of y. So the domain is any value of x except 7. Here's a simple one. The domain of f of g of x, well, if f of x is all real numbers, because it's a polynomial, g of x is all real numbers because it's a polynomial, f of g of x is all real numbers, done. That's easy. This is a fun one. We know that f of x, the domain is x is not equal to 0, and g of x, because it's a polynomial, is all real numbers. But when we do a domain of a composite function, whatever our output here in g of x has to be the input of f. So it's not just x not equaling 0, it's the input of the function cannot be 0. So we always do the inside function first. So what's the domain of g of x? All real numbers. Okay, that makes life easy. So we always look at the inside function first. Now we go to function f. We go to the outside function. And we know that the input cannot be 0. Well, our input is g of x. So the domain of our composite function is all values of x except 5. Now you'll notice that we didn't find the composite function, although we can tell by looking that it's 1 over x minus 5. But I didn't need to know the composite function to find the domain. I only need to know the two original functions. Now, this is a good one because both functions have domains. So the first one, if we're doing f of g of x, the domain here is x has to be greater than or equal to -3. Highlight it, put a cloud around it, put a big star by it or something, because no matter what, x has to be greater than or equal to -3. Because if you try to put in a number less than -3 in here, you get an imaginary g of x. You can't even put that into f of x to get a real number out. So the only way to ensure that you have an input for f is to ensure that g of x is real, is to make sure that x is greater than or equal to -3. So here's my graph for g of x. Now we're told that the input of f, we move to the outside function, the input of f cannot be 0, which means that square root can't be 0, solve for x, and you get x cannot equal -3. So that graph is, there's an open circle at -3 and it goes in both directions. We're one step away from the domain. I've got this, which is this graph, and I got this, which is this graph. Both of them must be true. Both of them must be true. Because if I pick a number out here to the left of -3, I won't even get a real number value of g of x, much less a real number value for f. So both have to be true. Where do they overlap? Where is this and this true? X is greater than -3. Not greater than or equal to, just greater than -3. That is the domain of the composite function, and you'll notice that nowhere did I ever find the composite function itself, which is 1 over the square root of x plus 3. This last one is one of my all-time favorites. I would not give you one this difficult on a test or a quiz without having shown you in advance absolutely how to do it. So I want to know the domain of f of g of x. Here's f of x. Here's g of x. Here's my domain for f. Here's my domain for g. Well, if I want to find the domain of f of g of x, absolutely x cannot equal 0. Because if x equals 0, I get 1 over 0 in here. I have f of, that's not even defined. So no matter what, x cannot be 0. So I start with the inside function. Like I said, put a box around it, a cloud, a star, something. Because no matter what, that has to be true, because that goes to the very beginning of the problem. Remember, we start with x, then get g of x, then get f of g of x. No matter what, that has to be true. So now we go to the outside function, which is the square root of x minus 4. Sorry about that break there. Get back to sharing my screen with you. Alrighty, so we know that when we go to the outside function, the domain for the outside function is the input has to be greater than or equal to 4. Well, the input for f is 1 over x squared. So 1 over x squared has to be greater than or equal to 4. Now, we can multiply both sides of this inequality by x squared because we know x squared will never be negative because we're dealing with real numbers. So we can do that without having to worry about sign changes. divide both sides by 4 because that doesn't affect the direction of the sign. Then I'm going to rewrite it this way. Now, we've gone over this before. What is the square root of x squared? It's not x. What is it? It's the absolute value of x. And when you have an absolute value less than, that means x has to be in between the two the positive and the negative versions of that. So here's our second function. So this is our function. You might think this is our domain of f of g of x, but you'll notice we have to account for this. The x cannot be 0. So the complete domain of f of g of x is all numbers between -1/2 and 1/2 inclusive, except 0. And if you want to see why that is, I recommend you go to Graph or Desmos or whatever you use to graph functions and graph f of g of x, which would be the square root of 1 over x squared minus 4. Graph that and you'll see why this is your domain and you need both parts. That's all I have for you right now. Have a great day.